When it comes to dealing with algebra and topics other than geometry, one of the most powerful features of GeoGebra is to use sliders to help you control parameters. So what I'm going to do in this video is show you how to graph transformations of the sine function so that we can use the sliders to control the parameters. We've already gone over how to create sliders, so I've already created the four here that I'm going to use. The exact values you put on these aren't particularly important. I've run I believe, from -2 to 2 by point, or from -5 to 5 by 0.1 increments. I've done the same thing with B and D. K is going to control the horizontal stretch and shrink, so I've run that from 0 to 3 by small increments. Then I can go down here and just plot the function. I'm going to call it f of x equals, I can do a times sine of k times x minus b plus d, and create that function, which is now controlled by the sliders. So d is your vertical shift. You can see those effects on the graph. B is the phase shift, as we call it in trig, or the horizontal shift. Let me move it over so we can see a little more of the formula at the same time. K is what controls the period or the frequency. The period of a trig graph is 2 pi over k, so as k gets bigger, the graph gets skinnier. And as k gets closer to 0, the graph gets wider. And then A would control the amplitude of the graph. Okay. So again, if we define sliders, we then have parameters or variables with those labels that we can use in functions, and we can do things like look at ax squared plus bx plus c, for instance. But here was an example of the sine function.